Welcome to the I Can't Sleep podcast, where I read random articles from across the web to bore you to sleep with my soothing voice. I'm your host, Benjamin Boster. Today's episode is from a Wikipedia article titled Linux. Linux is a family of open source Unix-like operating systems based on the Linux kernel, an operating system kernel first released on September 17, 1991 by Linus Torvalds. Linux is typically packaged as a Linux distribution, distro, which includes the kernel and supporting system software and libraries, many of which are provided by the GNU project. Many Linux distributions use the word Linux in their name, but the Free Software Foundation uses and recommends the name GNU Linux to emphasize the use and importance of GNU software in many distributions, causing some controversy. Popular Linux distributions include Debian, Fedora Linux, Arch Linux, and Ubuntu. Commercial distributions include Red Hat Enterprise Linux and SUSE Linux Enterprise. Desktop Linux distributions include a windowing system, such as X11 or Wayland, and a desktop environment such as GNOME or KDE Plasma. Distributions intended for servers may not have a graphical user interface at all, or include a solution stack such as LAMP. Because Linux is freely redistributable, anyone may create a distribution for any purpose. Linux was originally developed for personal computers based on the Intel x86 architecture, but has since been ported to more platforms than any other operating system. Because of the dominance of Linux-based Android on smartphones, Linux, including Android, has the largest installed base of all general-purpose operating systems, as of May 2022. Linux is, as of March 2024, used by around 4% of desktop computers. The Chromebook, which runs the Linux kernel-based Chrome OS, dominates the U.S. K-12 education market and represents nearly 20% of sub-$300 notebook sales in the U.S. Linux is the leading operating system on servers. Over 96.4% of the top 1 million web servers operating systems are Linux. Leads other big iron systems, such as mainframe computers, and is used on all of the world's 500 fastest supercomputers as of November 2017, having gradually displaced all competitors. Linux also runs on embedded systems, i.e., devices whose operating system is typically built into the firmware and is highly tailored to the system. This includes routers, automation controls, smart home devices, video game consoles, televisions, Samsung and LG smart TVs, automobiles, Tesla, Audi, Mercedes-Benz, Hyundai, and Toyota, and spacecraft, Falcon 9 rocket, Dragon Crew capsule, and the Perseverance rover. Linux is one of the most prominent examples of free and open source software collaboration. The source code may be used, modified, and distributed commercially or non-commercially by anyone under the terms of its respective licenses, such as the GNU General Public License, GPL. The Linux kernel, for example, is licensed under the GPL v2, with an exception for system calls that allows code that calls the kernel via system calls not to be licensed under the GPL. The Unix operating system was conceived and implemented in 1969 at AT&T's Bell Labs in the United States by Ken Thompson, Dennis Ritchie, Douglas McElroy, and Joe Osana. First released in 1971, Unix was written entirely in assembly language, as was common practice at the time. In 1973, in a key pioneering approach, it was rewritten in the C programming language by Dennis Ritchie, except for some hardware and I/O routines. The availability of a high-level language implementation of Unix made its porting to different computer platforms easier. Due to an earlier antitrust case forbidding it from entering the computer business, AT&T licensed the operating system's source code as a trade secret to anyone who asked. As a result, Unix grew quickly and became widely adopted by academic institutions and businesses. In 1984, AT&T divested itself of its regional operating companies and was released from its obligation not to enter the computer business. Freed of that obligation, Bell Labs began selling Unix as a proprietary product, where users were not legally allowed to modify it. Onyx Systems began selling early microcomputer-based Unix workstations in 1980. Later, Sun Microsystems, founded as a spin-off of a student project at Stanford University, also began selling Unix-based desktop workstations in 1982. While Sun workstations did not use commodity PC hardware, for which Linux was later originally developed, it represented the first successful commercial attempt at distributing a primarily single-user microcomputer that ran a Unix operating system. With Unix increasingly locked in as a proprietary product, the GNU project, started in 1983 by Richard Stallman, had the goal of creating a complete Unix-compatible software system composed entirely of free software. Work began in 1984. Later, in 1985, Stallman started the Free Software Foundation and wrote the GNU General Public License, GNU GPL, in 1989. By the early 1990s, many of the programs required in an operating system, such as libraries, compilers, text editors, a command line shell, and a windowing system, were completed, although low-level elements such as device drivers, daemons, and the kernel, called GNU Herd, were stalled and incomplete. Minix was created by Andrew S. Tannenbaum, a computer science professor, and released in 1987 as a minimal Unix-like operating system targeted at students and others who wanted to learn operating system principles. Although the complete source code of Minix was freely available, the licensing terms prevented it from being free software until the licensing changed in April 2000. Although not released until 1992 due to legal complications, the development of 386BSD, from which NetBSD, OpenBSD, and FreeBSD descended, predated that of Linux. Linus Torvalds had stated on separate occasions that if the GNU kernel or 386BSD had been available at the time, 1991, he probably would not have created Linux. While attending the University of Helsinki in the fall of 1990, Torvalds enrolled in a Unix course. The course used a Microvax minicomputer running Ultrix, and one of the required texts was Operating Systems Design and Implementation by Andrew S. Tannenbaum. This textbook included a copy of Tannenbaum's Minix operating system. It was with this course that Torvalds first became exposed to Unix. In 1991, he became curious about operating systems. Frustrated by the licensing of Minix, which at the time limited it to educational use only, he began to work on his operating system kernel, which eventually became the Linux kernel. On July 3, 1991, to implement Unix system calls, Linus Torvalds attempted unsuccessfully to obtain a digital copy of the POSIX standards documentation. After not finding the POSIX documentation, Torvalds initially resorted to determining system calls from Sun OS documentation owned by the university for use in operating its Sun Microsystems server. He also learned some system calls from Tannenbaum's Minix text. Torvalds began the development of the Linux kernel on Minix, and applications written for Minix were also used on Linux. Later, Linux matured and further Linux kernel development took place in Linux systems. GNU applications also replaced all Minix components because it was advantageous to use the freely available code from the GNU project with the fledgling operating system. Code licensed under the GNU GPL can be reused in other computing programs as long as they also are released under the same or compatible license. Torvalds initiated a switch from his original license, which prohibited commercial redistribution, to the GNU GPL. Developers worked to integrate GNU components with the Linux kernel, creating a fully functional and free operating system. Linus Torvalds had wanted to call his invention Freaks, a portmanteau of free, freak, and X, as an allusion to Unix. During the start of his work on the system, some of the project's makefiles included the name Freaks for about half a year. Initially, Torvalds considered the name Linux, but dismissed it as too egotistical. To facilitate development, the files were uploaded to the FTP server of FunNet in September 1991. Ari Lemke, Torvalds' co-worker at the Helsinki University of Technology, HUT, who was one of the volunteer administrators for the FTP server at the time, did not think that Freaks was a good name, so he named the project Linux on the server without consulting Torvalds. Later, however, Torvalds consented to Linux. According to a newsgroup post for Torvalds, the word Linux should be pronounced Linux, with a short I as in print and a U as in put. To further demonstrate how the word Linux should be pronounced, he included an audio guide with the kernel source code. However, in this recording, he pronounces Linux as Linux, with a short but close front unrounded vowel, instead of a near close near front unrounded vowel, as in his newsgroup post. The adoption of Linux in production environments, rather than being used only by hobbyists, started to take off first in the mid-1990s in the supercomputing community, where organizations such as NASA started to replace their increasingly expensive machines with clusters of inexpensive commodity computers running Linux. Commercial use began when Dell and IBM, followed by Hewlett-Packard, started offering Linux support to escape Microsoft's monopoly in the desktop operating system market. Today, Linux systems are used throughout computing, from embedded systems to virtually all supercomputers, and have secured a place in server installations such as the popular LAMP application stack. The use of Linux distributions in home and enterprise desktops has been growing. Linux distributions have also become popular in the notebook market, with many devices shipping with customized Linux distributions installed, and Google released their own Chrome OS designed for netbooks. Linux's greatest success in the consumer market is perhaps the mobile device market, with Android being the dominant operating system on smartphones and very popular on tablets, and more recently on wearables. Linux gaming is also on the rise, with Valve showing its support for Linux and rolling out SteamOS, its own gaming-oriented Linux distribution, which was later implemented in their Steam Deck platform. Linux distributions have also gained popularity with various local and national governments, such as the federal government of Brazil. Linus Torvalds is the lead maintainer for the Linux kernel and guides its development, while Greg Kroah-Hartman is the lead maintainer for the stable branch. Zoe Kuhlman is the executive director of the Free Software Foundation, which in turn supports the GNU components. Finally, individuals and corporations develop third-party non-GNU components. These third-party components comprise a vast body of work and may include both kernel modules and user applications and libraries. Linux vendors and communities combine and distribute the kernel, GNU components, and non-GNU components with additional package management software in the form of Linux distributions. Many developers of open source software agree that the Linux kernel was not designed but rather evolved through natural selection. Torvalds considered that although the design of Unix served as a scaffolding, Linux grew with a lot of mutations, and because the mutations were less than random, they were faster and more directed than alpha particles in DNA. Eric S. Raymond considers Linux's revolutionary aspects to be social, not technical. Before Linux, complex software was designed carefully by small groups, but Linux evolved in a completely different way. From nearly the beginning, it was rather casually hacked on by huge numbers of volunteers, coordinating only through the internet. Quality was maintained not by rigid standards or autocracy, but by the naively simple strategy of releasing every week and getting feedback from hundreds of users within days, creating a sort of rapid Darwinian selection on the mutations introduced by developers. Brian Cantrill, an engineer of a competing OS, agrees that Linux wasn't designed, it evolved, but considers this to be a limitation, proposing that some features, especially those related to security, cannot be evolved into. This is not a biological system at the end of the day, it's a software system. A Linux-based system is a modular Unix-like operating system, deriving much of its basic design from principles established in Unix during the 1970s and 1980s. Such a system uses a monolithic kernel, the Linux kernel, which handles process control, networking, access to the peripherals, and file systems. Device drivers are either integrated directly with the kernel or added as modules that are loaded while the system is running. The GNU userland is a key part of most systems based on the Linux kernel, with Android being the notable exception. The GNU C library, an implementation of the C standard library, works as a wrapper for the system calls of the Linux kernel necessary to the kernel user space interface. The toolchain is a broad collection of programming tools vital to Linux development, including the compilers used to build the Linux kernel itself, and the kernels implement many basic Unix tools. The GNU project also develops Bash, a popular CLI shell. The graphical user interface, or GUI, used by most Linux systems is built on top of an implementation of the X Window system. More recently, the Linux community has sought to advance to Wayland as the new display server protocol in place of X11. Many other open source software projects contribute to Linux systems. Installed components of a Linux system include the following: a bootloader, for example GNU Grub, Lilo, SysLinux, or System dboot. This is a program that loads the Linux kernel into the computer's main memory by being executed by the computer when it is turned on and after the firmware initialization is performed. And init programs such as the traditional sysvinit and the newer systemd, OpenRC, and Upstart. This is the first process launched by the Linux kernel and is at the root of the process tree. It starts processes such as system services and login prompts, whether graphical or in terminal mode. Software libraries which contain code that can be used by running processes. On Linux systems using ELF format executable files, the dynamic linker that manages the use of dynamic libraries is known as ld-linux.so. If the system is set up for the user to compile software themselves, header files will also be included to describe the programming interface of installed libraries. Besides the most commonly used software library on Linux systems, the GNU C library, glibc, there are numerous other libraries, such as SDL and Mesa. The C standard library is the library necessary to run programs written in C on a computer system, with the GNU C library being the standard. It provides an implementation of the POSIX API, as well as extensions to that API. For embedded systems, alternatives such as Muscle, eglibc, a glibc fork once used by Debian, and uclibc, which was designed for uClinux, have been developed, although the last two are no longer maintained. Android uses its own C library, Bionic. However, Muscle can additionally be used as a replacement for glibc on desktop and laptop systems, as seen on certain Linux distributions like Void Linux. Basic Unix commands, with GNU kernels being the standard implementation. Alternatives exist for embedded systems, such as the copyleft BusyBox, and the BSD licensed toy box. Widget toolkits are the libraries used to build graphical user interfaces, GUIs, for software applications. Numerous widget toolkits are available, including GTK and Clutter developed by the Genome Project, Qt developed by the Qt Project, and led by the Qt Company, and Enlightenment Foundation Libraries, EFL, developed primarily by the Enlightenment team. A package management system such as DPKG and RPM. Alternatively, packages can be compiled from binary or source tarbles. User interface programs such as command shells or windowing environments. The user interface, also known as the shell, is either a command line interface, CLI, a graphical user interface, GUI, or controls attached to the associated hardware, which is common for embedded systems. For desktop systems, the default user interface is usually graphical, although the CLI is commonly available through terminal emulator windows or in a separate virtual console. CLI shells are text-based user interfaces, which use text for both input and output. The dominant shell used in Linux is the Bourne Again shell, Bash, originally developed for the GNU project. Most low-level Linux components, including various parts of the userland, use the CLI exclusively. The CLI is particularly suited for automation of repetitive or delayed tasks and provides very simple inter-process communication. On desktop systems, the most popular user interfaces are the GUI shells, packaged together with extensive desktop environments, such as KDE Plasma, Genome, Mate, Cinnamon, LXDE, Pantheon, and XFCE, though a variety of additional user interfaces exist. Most popular user interfaces are based on the X Windows system, often simply called X. It provides network transparency and permits a graphical application running on one system to be displayed on another, where a user may interact with the application. However, certain extensions of the X Windows system are not capable of working over the network. Several XDisplay servers exist, with a reference implementation x.org server being the most popular. Server distributions might provide a command line interface for developers and administrators, but provide a custom interface for end users, designed for the use case of the system. This custom interface is accessed through a client that resides on another system, not necessarily Linux-based. Several types of window managers exist for X11, including tiling, dynamic, stacking, and compositing. Window managers provide means to control the placement and appearance of individual application windows and interact with the X Windows system. Simpler X window managers such as DWM, Ratpoison, or i3WM provide a minimalist functionality, while more elaborate window managers such as FVWM, Enlightenment, or Window Maker provide more features such as built-in taskbar and themes, but are still lightweight when compared to desktop environments. Desktop environments include window managers as part of their standard installations, such as Mutter, Genome, Kwin, KDE, or XFWM, Xface, although users may choose to use a different window manager if preferred. Wayland is a display server protocol intended as a replacement for the X11 protocol. As of 2022, it has received relatively wide adoption. Unlike X11, Wayland does not need an external window manager and compositing manager. Therefore, a Wayland compositor takes the role of the display server, window manager, and compositing manager. Weston is the reference implementation of Wayland, while Genome's Mutter and KDE's Kwin are being ported to Wayland as standalone display servers. Enlightenment has already been successfully ported since version 19. Additionally, many window managers have been made for Wayland, such as Sway or Hyperland, as well as other graphical utilities such as Waybar or Rofi. Linux currently has two modern kernel user space APIs for handling video input devices: V4L2 API for video stream and radio, and DVB API for digital TV reception. Due to the complexity and diversity of different devices, and due to the large number of formats and standards handled by those APIs, this infrastructure needs to evolve to better fit other devices. Also, a good user space device library is a key to the success of having user space applications to be able to work with all formats supported by those devices. The primary difference between Linux and many other popular contemporary operating systems is that the Linux kernel and other components are free and open source software. Linux is not the only such operating system, although it is by far the most widely used. Some free and open source software licenses are based on the principle of copyleft, a kind of reciprocity, and any work derived from a copyleft piece of software must also be copyleft itself. The most common free software license, the GNU General Public License, GPL, is a form of copyleft and is used for the Linux kernel and many of the components from the GNU project. Linux-based distributions are intended by developers for interoperability with other operating systems and established computing standards. Linux systems adhere to POSIX, SUS, LSB, ISO, and ANSI standards where possible, although to date only one Linux distribution has been POSIX 1 certified, Linux FT. Free software projects, although developed through collaboration, are often produced independently of each other. The fact that the software licenses explicitly permit redistribution, however, provides a basis for larger scale projects that collect the software produced by standalone projects and make it available all at once in the form of a Linux distribution. Many Linux distributions manage a remote collection of system software and application software packages available for download and installation through a network connection. This allows users to adapt the operating system to their specific needs. Distributions are maintained by individuals, loose-knit teams, volunteer organizations, and commercial entities. A distribution is responsible for the default configuration of the installed Linux kernel, general system security, and more generally, integration of the different software packages into a coherent whole. Distributions typically use a package manager such as apt, yum, zypper, pacman, or portage to install, remove, and update all of a system's software from one central location. A distribution is largely driven by its developer and user communities. Some vendors develop and fund their distributions on a volunteer basis, Debian being a well-known example. Others maintain a community version of their commercial distributions, as Red Hat does with Fedora and SUSE does with OpenSUSE. In many cities and regions, local associations known as Linux user groups, LUGs, seek to promote their preferred distribution and, by extension, free software. They hold meetings and provide free demonstrations, training, technical support, and operating system installation to new users. Many internet communities also provide support to Linux users and developers. Most distributions and free software/open source projects have IRC chat rooms or news groups. Online forums are another means of support, with notable examples being linuxquestions.org and the various distribution-specific support and community forums, such as ones for Ubuntu, Fedora, and Gentoo. Linux distributions host mailing lists. Commonly, there will be a specific topic, such as usage or development for a given list. There are several technology websites with a Linux focus. Print magazines on Linux often bundle cover disks that carry software or even complete Linux distributions. Although Linux distributions are generally available without charge, several large corporations sell, support, and contribute to the development of the components of the system and free software. An analysis of the Linux kernel in 2017 showed that well over 85% of the code was developed by programmers who are being paid for their work, leaving about 8.2% to unpaid developers and 4.1% unclassified. Some of the major corporations that provide contributions include Intel, Samsung, Google, AMD, Oracle, and Facebook. Several corporations, notably Red Hat, Canonical, and SUSE, have built a significant business around Linux distributions. The free software licenses on which the various software packages of a distribution built on the Linux kernel are based explicitly accommodate and encourage commercialization. The relationship between a Linux distribution as a whole and individual vendors may be seen as symbiotic. One common business model of commercial suppliers is charging for support, especially for business users. A number of companies also offer a specialized business version of their distribution, which adds proprietary support packages and tools to administer higher numbers of installations or to simplify administrative tasks. Another business model is to give away the software to sell hardware. This used to be the norm in the computer industry, with operating such as CP/M, Apple DOS, and versions of the classic Mac OS before 7.6 freely copyable but not modifiable. As computer hardware standardized throughout the 1980s, it became more difficult for hardware manufacturers to profit from this tactic, as the OS would run on any manufacturer's computer that shared the same architecture. Most programming languages support Linux either directly or through third-party community-based ports. The original development tools used for building both Linux applications and operating system programs are found within the GNU toolchain, which includes the GNU Compiler Collection, GCC, and the GNU Build System. Amongst others, GCC provides compilers for Ada, C, C++, Go, and Fortran. Many programming languages have a cross-platform reference implementation that supports Linux. For example, PHP, Perl, Ruby, Python, Java, Go, Rust, and Haskell. First released in 2003, the LLVM project provides an alternative cross-platform open-source compiler for many languages. Proprietary compilers for Linux include the Intel C++ compiler, Sun Studio, and IBM XL C++ compiler. BASIC is available in procedural form from QB64, Pure Basic, YBasic, GLBasic, Basic4GL, XBasic, WXBasic, SDLBasic, and Basic 256, as well as object-oriented through Gambas, FreeBasic, B4X, Basic for Qt, Phoenix Object Basic, NS Basic, ProvideX, Chipmunk Basic, RapidQ, and Zojo. Pascal is implemented through GNU Pascal, Free Pascal, and Virtual Pascal, as well as graphically via Lazarus, PascalABC.net, or Delphi using FireMonkey, previously through Borland Killix. A common feature of Unix-like systems, Linux includes traditional specific-purpose programming languages targeted at scripting, text processing, and system configuration and management in general. Linux distributions support shell scripts, awk, sed, and make. Many programs also have an embedded programming language to support configuring or programming themselves. For example, regular expressions are supported in programs like grep and locate. The traditional Unix message transfer agent sendmail contains its own Turing complete scripting system, and the advanced text editor GNU Emacs is built around a general-purpose Lisp interpreter.